Hello, and welcome back to Tech Talk with Toby. This is, of course, Toby, the one and only and the most handsome. So basically, what's going on today is I got a request from another tech guy that's in the tech field. Specifically, he deals with security cameras and door controls and like basic physical security for a building and organizations and that sort of stuff. And what he wanted was a two-part thing. He wanted a basic tutorial on how to use the network protocol analyzer Wireshark. Specifically, he wants to use this for some of the cheaper Chinese devices that they use to sell to their customers that are on a budget. But the biggest concern that he had about them was that they might actually have backdoors that are, reaching out to somewhere on the internet and sending information, aggregating information to a server or a client, somewhere that he didn't necessarily want, which could or could not be malicious, truthfully. And that's what the point of this is. A lot of people confuse Wireshark for something that you can use to track people's activity. While you can do that, it's not really made for that sort of thing. You're going to want to use like a web filter or a proxy server or something like that and actually use that to aggregate all your data, and put it into graphs for each individual user and IP address and that sort of stuff. Basically what Wireshark is, it captures all the packets that are going through your networks and analyzes the specific protocol that they're using. Once you've got it narrowed down to the actual stream of data that you want, you can actually follow that stream and figure out what somebody's doing or what a particular device or service is doing on a certain port. For instance, when I started up Wireshark here on my house network today, I noticed that I was getting a lot of SNMP traffic. And basically what SNMP traffic is it's traffic that's sent back and forth between a client and, let's say, either a network switch, a router, in this case it was printers. Basically what was going on is I was seeing these SNMP requests going out to IP addresses that I know are not on my subnet. I use 192.168.1.1 for my local subnet in my IP address scheme, and it was reaching out to 10.0.3.something, 10.0.4.something.1.something. And I recognized the IP addresses it was going to. In this case, it was going out to some corporate printers that are on some of my clients' networks, and it was also reaching out to some stuff that I use over some remote VPNs and whatnot. And that's just the sort of stuff that this is great for. Or, for instance, I've been noticing that my Time Warner cable connection, don't get me started about them, is like kind of lagging sometimes, especially when I'm playing YouTube videos or playing a game, any type of streaming activity. It'll kind of choke up on me sometimes. And what I found out in Wireshark is that every couple minutes, actually, my internet connection craps out on me, and everything that goes through there is listed in black for that particular time frame. And what that basically meant is that anything that's in black, anyway, this is color-coded, I'm going to show you that. Anything that was in black was either misconstrued data, it was coming back incorrect, it was sent out in the wrong order, or it just couldn't get it out in general. And that's the sort of stuff that Wireshark's really great for. In this case, what I'm going to do is I'm going to show you how to actually capture packets, and then I'm going to show you how all the color coding works and whatnot. And then later on in the video, what we're going to do is I'm actually going to show you how to dig down deep into it, and we're going to trace all the packets that go in and out of my computer, and then I'm going to show you how to actually follow a particular string. So for the particular guy, Steve, that actually asked for this video, what we're going to do is I'm going to show you how to use all the basics of Wireshark, and then I'm going to actually show you how to narrow it down to a specific IP address. So let's say you set up a camera on your test bench, and you want to see if there's any backdoors in it. You set it up, and just let it run for a couple hours, and you can capture it, and it'll show you all the connections and whatnot. And you can go through that stream right there of all those packets and connections and whatnot, and you can actually look at each one and see where it's leading out to. For instance, some of it would actually be pretty legitimate. I bought a camera here for my house, little Winbook one, IP address camera, and I have a server downstairs that I use to actually capture all the video and the pictures and whatnot and keep it on there. But I noticed some weird traffic that was coming out of it. And basically, this is a cheap knockoff Chinese camera, and there was some traffic that was going out to the manufacturer's website and then kicking back my public IP address, and I'm like, that seems malicious. Turns out that it wasn't. It was actually a feature that they never told me about. And basically what it was using dynamic DNS. It was sending my IP address out to their servers, and they had a free dynamic DNS server set up that you could use, so that in case your dynamic IP address changes throughout the year, which actually happens quite a bit when you're on home routers and that sort of stuff, when that dynamic IP address was changing, it was kicking it back over to the free dynamic DNS server, and then I could use their free dynamic DNS service to actually track my IP address and get into the IP address, the IP camera pretty easily. So sometimes stuff is legitimate, sometimes it's not, and it's malicious, and that's really what the Wireshark Network Protocol Analyzer is really for, so you can find out what that traffic is and why it's there. So without further ado, I'm going to go ahead and go over to a screen capture here and show you how to use Wireshark and narrow it down. Alright, we're over to the screen capture now. What I'm going to show you right now is actually how to use Wireshark. You can go directly over to wireshark.org and download the freeware version of Wireshark. I'm actually not even sure that there is a paid version. It's all made under the Open GPU license. They have it for all the popular platforms. Windows, they have Linux, OS X as well. As you can see here, I'm using Windows 8.1. So it works pretty stable on all the operating systems. I haven't really had much of an issue. One thing that I will actually note, something that you want to use in conjunction with Wireshark to actually reach out to a server and find out what it is what's called Nmap. And what Nmap basically is, Nmap is right here is the command line version. ZenMap is the one with the graphical user interface overlay. And basically what ZenMap is, you can type in an IP address. Let's see here. That's my computer right there, and you can hit scan. You can do the different types of scans and whatnot. I'm not even going to talk about Nmap and really how to use it. But what it's going to do is it's going to reach out to the IP address, whether it's local on the internet, and tell you what that server is. It's going to tell you basically what operating system it runs off of and all the different services and whatnot it is. So if you do find something malicious, you can run this on there and find out, are they coming through a proxy? Is this something that someone set up directly? Is it a mail server? Is it a web server? Is it Linux? Is it Windows? Whatnot. This is going to help quite a bit right here. Okay, without further ado, let's go ahead and open up Wireshark. It's a pretty small program. I think it was like 23 megabytes. Runs pretty quickly, actually. A very smooth little program. This is the newest version. I just downloaded this one right here, which is version 1.12.2. Let's see here. Okay, on the left-hand side, you have your interface list. This right here shows and lists all your interfaces that you have for this particular computer. As you can see from me, 4 available. My Bluetooth network connection. Not really sure what that would be used for, but that might be a little bit interesting. Here's my local area connection 12, which happens to be a VPN tunnel that I set up. Local area connection, the original one without a number on it, that is going to be your hardwired connection, which I'm not using. I'm on Wi-Fi. So what you're going to go ahead and do is select the connection that you want. Like I said, I'm on Wi-Fi, so I'm going to use that one. And all you have to do is hit start here. Alright, and as you can see, what's coming through now, over in this area, these are all of your packets that are coming over the network. This is going to show everything that basically this computer can see. Now, as I was saying earlier, everything here is color-coded, as you can see. You have blue, light blue, green, pink, black, and that sort of thing. Basically, there's a couple different ones you really need to know. Green, just like this one right here, that's all TCP traffic. Anything that's actually labeled as green is going to be TCP traffic. Dark blue, which I'm not sure I have any on here right now. Not seeing any dark blue ones. Dark blue is going to be DNS. So any DNS request to or from a DNS server, whether it's Google's or a local one on your network, is going to be light blue. Let's see here. I'm sorry, no, that would be dark blue, my bad. Light blue is UDP traffic, which if you're familiar with network protocols, and if you're using this program, my God, I hope you are, the UDP is just slightly different than TCP. It really doesn't require a connection back and an acknowledgement that the packet really went. It's just kind of like a one-way street. UDP really in this, and what you're going to be using this for, isn't all that important, but it could be. It could be. It really depends on what you're doing, and that's fine. So if you noticed up in here also, there's all these black ones, okay? These black ones, that doesn't seem quite right, okay? Basically what the black ones are is misconstrued data. That could be anything from you're having a bad latency connection and your packets aren't getting to or from correctly. That could be mismatched information, so something got construed somewhere on an outside server and came back wrong and the computer doesn't recognize it. In this case, remember how I was talking about earlier how my Time Warner connection is kind of crappy? and every couple minutes it does this. That's what I'm talking about right there. And what this is basically all the traffic within that time period went black because none of it was going out or coming in correctly. Now, right now, what we're looking at, this is your view, okay? There's basically two main parts of this program. There's your view right here, and then there's your capture interface right here. Right now, we're simply just viewing. Now, to actually start capturing packets, you have to go up to here and hit Capture Filters. Now, as you can imagine, a filter streams out all this because this is a lot of information. I've been running this for like, what, 2 minutes now? And I've got all this right here already. I mean, this is just so much to go through, okay? And a lot of this is just normal this could be anyone just doing a Google search. For instance, right here, this is an ARP request, so this is going to be something coming from or to one of my routers or something like that. It's just a bunch of stuff that you really don't necessarily need to be sifting through. Right here you have some broadcast, which I'm not really sure what that is. I have to go look at it. It's Dropbox right there. You can see it actually lists that one. It's not many programs are actually listed, but sometimes it does if it recognizes the port and service and whatnot. Okay, so basically we got to figure out how to filter out all of this stuff, because it's still coming through, as you can see. I mean, it's just pouring in. My particular IP address on my local computer here is 192.168.1.114. Oh, wow, it isn't actually letting me do that. So what you have to do, you can't just type it in. You have to use a filter expression. And you can look up their filter expressions online. Some of them are actually listed in here. There are so many filter expressions. I mean, it looks like there's maybe 400 or 500 in there, quite a bit. The particular one to look at a particular IP address is IP.addr. Okay, so what you use is filter expressions on here to actually filter out all of this stuff, because there is so much to go through, as you can see here. I mean, I've already got thousands of packets that have come through. My particular IP address for this computer, which is what we're going to use for the example, is 192.168.1.114. So you type in IP dot, and it's going to come up with your address right here, which is actually the first expression. IP.addr. That is an IP address specific function. So you hit equals 192.168.1.114, and as you can see, this is going green again, which means we can use that expression. You can either hit enter or apply. I'm going to hit enter here. And now, as you can see, everything that's in this list is only the stuff that's coming out of or going to my computer. And as you see at the very beginning, here's some of that black traffic that wasn't going out right or coming back in correctly. Alright, now basically you want to look at one of your packets here. Okay, we're going to go ahead and go up here so we can pause this a little bit basically. You have a couple different things here. This is your number right here, which lists the packet number or connection number. You have your time and date right here. And then your source IP address. With this particular one, we're looking at an SNMP packet, which is what I was talking about earlier. Remember those printers I was talking about? And the traffic that I was getting was reaching out to an IP address that isn't on my subnet? That's one of them right there. My source IP address is 192.168.1.114. As you can see, that is my particular IP address for this computer. The destination was 10.0.3.59. Well, if you go over to command prompt here, as you can see, my subnet mask is 255.255.255.0/21 on 192.168.1.1 with an IP address of 1.14. Why would it be reaching out to 10.0.3.59 or .1.4? Okay, that doesn't seem right. Okay, well basically I looked into this and I actually recognized those particular IP addresses. Looked up the protocol name here, SNMP. And basically what SNMP is, it configures network devices through a daemon and whatnot. And since my computer works with those devices a lot, because they're one of my clients, they're big laser printers basically over at his office, it's still looking for those, even though I'm not at the office anymore, and that's some cache data and that sort of stuff. Now that doesn't really make a huge difference. You get a lot of that sort of traffic going on, it can make a difference. So you can go through and track down all that if you want. Okay, so now this is something I already know about, because I've been looking at this. But basically, you can look through here and go, okay, well, something doesn't quite look right and whatnot, Okay, so you have a TCP stream here, and you don't know what that is, okay? So you're looking at your source IP address is 192.168.1.114. destination 74.125.69.189, okay? You can right-click on this and follow TCP stream. And what this is going to bring up is probably where it's going to. And if you filter by HTTP traffic, you're only going to be getting website traffic. So you can find out what the website is or server that it's connecting to. In this case, it's in the very beginning of the packet header, client-channel.google.com. So if I go to client-channel.google.com, it'll probably come up with the website that this computer was trying to view or that's connected to. Now, that doesn't necessarily mean that it's connected to the website and like viewing content. That could be a server right there, which is okay as well. Now, in one of the particular cases that I saw when I opened this up a couple minutes ago, I have this right here. I have a request going out from my computer of 192.168.1.114 to 74.125.69.189. It's in gray, which means that the connection failed, okay? But there's also something coming back from that server, and I don't know what it is. So we can go over to our web browser here. 192, or I'm sorry, what was the actual IP address there? Let's see. 74.125. So we have 74.125.69, and what was the last octet here? That's 69.189. Okay. Looks like that's Google. That's actually one of Google's HTTP servers on port 80. Okay, so something was going out to it, my computer, when I tried to do a Google search, and it came back, it didn't work. But now it's working. And that's kind of what this sort of stuff is right here. You go through and you can narrow down the stream to whatever it is. And as you can see, there is just so much traffic. Because, I mean, this is just my computer. If you go over the entire network, you can get just millions of packets racked up really quickly. So basically right now we're just in the viewing. That doesn't really mean anything. You know, you can sit there and look at traffic and whatnot all day long, but since we're all busy IT guys, we don't have time for that. So what you can do, and in Steve's particular case, you want to do see what's going on in those cameras over time and see if you can find any backdoors in them. What you want to do is go up to Capture here, Capture Filters. Okay? Now once you're into Capture, this right here is the entire thing. You can go into interface and tell it which interface to capture on. Obviously, I'm already on Wi-Fi, so that's fine. Okay, so you go over to Capture Filters, and this is going to be just like the View filters, only you're going to put these filters on what you're going to capture packets for. We're going to go ahead and do IP address here. When you hit IP address, 192.168.0.1 is the default one. That's just a default as a filler. In my case, we're going to use my computer, which is 1.114. Now, you can do other filters as well. You can add these filters in here, and you can put in, TCP only or whatnot, and that's fine. You can stack filters as an expression. That's not much of an issue at all. Okay, so you want to hit OK. So what this is going to be doing here with this particular filter, now there's only a couple different filters actually listed here on Capture. Believe me, there are 1,000 more, and you can look a lot of these up on their wiki page. Just hit OK, and then you go to Capture Stop. See, it's already capturing for me right now. It automatically started capturing as soon as I hit that OK right there. So let's go ahead and hit Capture Stop. Okay. Now, you have those packets actually captured into a file that you can use later on, A, for logging. If there's a criminal investigation of some sort, you can use it as evidence. Or just, personally, if you want to sit here and lock down all that traffic over the next couple days and analyze it to see if there's a back door in there. So what you can do is save as. Now, this right here is going to go into a Wireshark p.p capping file. You can save that as, whatever you want, save it wherever you want and whatnot, and that's fine. You can come back to it and open it later in Wireshark. You can open it in other packet analyzers. There are plenty of other packet analyzers out there that can open Wireshark PCAP files, and there are a bunch of different other programs that can do that. Now, what I would suggest is once you've actually found a connection that you don't necessarily like, let's pick this one right here, 74.125.69.189. Okay, what you can do with that, let's say that you put that into your web browser and nothing actually came back. It doesn't look like anything, like a web browser or I'm sorry, a web server or anything like that. This is where Nmap comes in, okay? So what you can do is you can go over to Nmap here. I use Nmap because I like graphical user interfaces because I don't like typing so much. you can type in that IP address. 74.125.69.189. Now, I'm not actually going to run this scan right here and figure out what that is, but you can do your different types of scans and whatnot. Like I said, ZenMap and Nmap is a totally different tutorial. I'm not going to go through all that. But this right there will kick back and tell you what that server is and why your computer or device would be connecting out to that. At this point, I think I've done a good, very basic skimming the surface of Wireshark. Wireshark is such an intense program. You can do so much with this. It's a very versatile program. I've just showed you the surface of it. The best advice I can give you is go play with it. They got a really nice user manual too that explains what all these functions do. As a matter of fact, there's a really cool section in here just for telephone systems. As you can see, there's a lot of different telephone system protocols in there. So if you're doing anything with telephony systems, especially voice over IP these days, and there's something wrong, you can use Wireshark to find out what's going on. I think I did a pretty good job of just giving you the basics of this, and Steve, I think I answered your question. If I didn't, by all means, go ahead and send me a message and whatnot, and I'll take care of you. Other than that, I think we got it. Okay, now you know the basics of Wireshark and actually how to narrow that down to a specific IP address or device or even protocol with the filters. And you can do that on the capture or the view if you just want to see what's going on before you actually do capture. And you can let that sort of stuff run for a couple days and analyze what's going on. This would be great to use for something. Let's say that you look at your server rack and you see, man, my switch is just lit up constantly with traffic, but no one's here. Why? Well, this is great. Okay, that's what Wireshark's for. Go in there and look at that traffic and see what's going on. You can, see if there's is someone trying to hack into a server. Are there connections in there that are attempted or even active connections that shouldn't be there? That's what Wireshark is really for. It's a network protocol analyzer. So I think that's a great introduction to it. This is going to help you a lot in the security field. It's going to help you a lot with just general network diagnostics as well when something's not going wrong or congestion and whatnot. There are 1,000 different things you can do with Wireshark. I gave you, like I said, a very brief introduction to it. If you have any questions on how to use Wireshark or specifics of that sort of thing, go to the website and check it out and contact them. If you want to, feel free to send me a message, and I will do my best to help you out with that and answer your question. As always, thank you for watching.